Can everybody hear me okay? Is the mic working? Good? Awesome. Cool. Did they say they let Corey Quinn in here?
Sorry.
Yeah, okay. That's what I thought. Anyways, yeah, okay. Super excited to be here. It is like really hard to believe this is the 10th Monitorama. I've been involved with monitoring observability for basically the bulk of my career, and it was kind of the realization that it's been 10 years of Monitorama led me to this sort of reflective place where I was thinking about everything that's changed in the last 10 years. There's been a lot, and you know, what, if anything, what's driving that, and what maybe that might lead us to infer about the future. And so, yeah, just to like background, Pete did a pretty good job. This is me. I dropped out of a PhD in computer science like a million years ago. Worked on a bunch of startups, all in distributed systems of just some kind or another. Went from telecommunications, high-performance computing, data center orchestration, and finally landed in the cloud. I wasn't screaming at the time, but yeah, Librado, we were one of the very first cloud infrastructure monitoring companies, and then sold that to SolarWinds, exited that. SolarWinds acquired it in 2015, and I got to work a couple years there helping drive their cloud product strategy. We did a bunch of acquisitions like Papertrail, Pingdom, Loggly, and some others. Had some fun. After that, yeah, as Pete mentioned, I moved over to this place called HeavyBit. We're an early stage venture firm. We're deeply vertically focused on developer tools, develop first infrastructure, enterprise software, and so as you can imagine, monitoring observability continues to be a very active area of interest of mine, and I am actually supposed to very barely kind of have some guess of what's going to happen in the future. This just because near and dear to my heart, I went online. This is a picture of me. The last time I spoke at Monitorama, it was in Boston. It was 10 years ago. I gave a talk about data visualization. This is the best picture I could find online of it. So production quality has increased at this conference since then, a little bit, which is good. So I had to come back and get something that people can actually see. All right. Now, moving on to the task at hand. So a relatively new engineer, whether this is someone you're mentoring or someone in your team, comes and says, hey, I'm wiring something up. I need some observability. Like, you know, what should I use? And because you're an experienced engineer, you start with the normal call and response, and you say, well, it depends. And then you say, well, let's just go and take a look at what our options are. And this is a point in the movie where like the record scratches and it freeze frames, and they say, oh, you might be wondering how we got here. Because this looks like a hot mess. And it's certainly inscrutable and not at all welcoming to someone new to the craft. But much like any legacy system, and by legacy system I mean a system that makes money and keeps people employed, like any legacy system, when someone new shows up and says, oh my gosh, I can't believe how gross all this code is, I can't believe all the trade-offs that have been made, like how could you all have done this? And you say, well, there's this kind of natural progression of events. And the lens that I think especially, it's not the only thing that impacted all of these, but I do think as I was thinking through and trying to find some common narrative threads, in IT, as an industry, it's a case study of Clayton Christensen, who wrote The Innovator's Dilemma, notion of a disruptive innovation, a IT platform shift. And these are things, they rewrite the rules first slowly and then very quickly when they hit, or it feels quickly. And so why do these happen, other than just the shiny object syndrome, which I do admit helps drive them, but I'd like to think is not the only reason. And they are because These platform shifts promise new features and capabilities, the ability to build things we couldn't before, generally some significant performance improvements, and these can be performance not just in terms of like raw compute and memory, but also cost performance, flexibility, removing, this one's a little more subtle. A lot of these help remove communication coordination overhead, and which is a very pernicious kind of cost. And if you think of your mythical man month, Frederick Brooks, anything you can do to reduce coordination overhead helps you scale your team. And importantly, usually you're trading these off. You don't usually get all of them. And also, they let us, which I think is most important, we consistently, which I think it just is great as us and humans, we don't stand pat and say, oh, good, now this is easier. We say, oh, good, now we can build something bigger and more ambitious than we ever have before. So the downside, the trade-offs, IT platform shifts, so they are, there's no free lunch, no silver bullets, incompatible with our existing solutions, usually. Also alien in terms of, and this is because the new thing lacks backwards compatibility because you don't actually know if the new thing is going to be the new thing, and so it doesn't make sense to have any of those constraints until you're way down that path. And at that point, everyone's adapting to the new thing, and there's less need for that. But yeah, workforce often needs to be retrained, business models need to be altered, and this usually leaves a gap, especially because in the early days of the new thing, it's commercially uninteresting. The market's not large enough, and the incumbents, whether those are projects or products, are motivated to believe that the new thing's not going to be the new thing. So with that in mind, the baseline I'm going to use for this, I mean, you could go all the way back to ENIAC or the beginning of IT, but we're just going to start, we're going to fast forward to the late 90s when your typical dot-com era architecture, scale up, proprietary, you got big iron machine from Sun if you were best in class, or if you were doing, just buying from a single vendor, maybe HP, IBM. This is the kind of infrastructure that all the large giants at the time were running. And you had system administrators manning the helm. So very first kind of platform shift I want to look at is the move from that to scale out commodity x86 servers and open source software. And then a specific example being the LAMP stack. And there's a bunch of coming lately providers who went and took this path, reducing costs for both hardware and software, and bringing rise the discipline of web operations. And this driving down of costs and making it easier to run larger fleets of servers starts to unlock some innovation. At the time, then this is where we're going to take our first look at monitoring. And prior, instead of just using proprietary tools, this is in my mind, and of course, like on Solaris or there were other platforms that were like system monitoring tools, but this is where I think we first took, like I said, a background in HPC, tools like Ganglia, which came from the University of Berkeley to run large scale-out clusters. Nagios was brought around in 2004, and we have this very simple workflow, but that works for the systems at the time. So like I said, first of all, everything works. And then second of all, don't ever change anything. Don't ship software. And if something goes wrong, Nagios will find it. We'll log in and fix it. And we'll rinse and repeat. Now, the big inflection point here, even though this is a relatively simplistic initial state, is that open source software has a much deeper impact than just reducing licensing costs. Open source also drove down barriers to collaborating across corporate boundaries, and maybe, I think more importantly, lowering the activation energy required to just put something out there and start working on it and start solving problems. And recently, I go so far, and you're going to see, because the whole rest of our story, like the open source never goes away, and yes, there's more commercial vendors coming in, and myself included. But I believe, and I firmly, that open source software is like the most positive, transformative force in the history of IT, and that this is something that is going to play out and has played out to date in observability and will continue as long as we're doing it. And every one of these projects starts the same way, where someone's just staring at a screen like really, really, really angry and decides like enough is enough with the current status quo and starts working on a new way to do things. And they can do this and share it freely with anyone. And in venture, we talk a lot about total addressable markets and TAM, which is like the acronym, and that need to be large enough to justify the investment and spending time on something. Well, open source software requires a TAM of 1, you, and the budget of your time. And you can start with that and build something around it. So, moving forward, the next in my worldview shift, and some of these overlap a little bit, but we're going to go through them sequentially. DevOps. So we had driven down the cost of procurement, and we'd increased the potential for collaboration and innovation. And then software started becoming SaaS. And so the release kind of processes and timelines that we had built and designed for shrink-wrap software do not work anymore. So in SaaS, this turns to be like, at best, like a quarterly release of just like doom and tears. And if you've never either experienced that, like I know some of you have, or you should, if you haven't, read the Phoenix Project. It's just this great novel, which, I mean, fiction, but does just an incredible job, the starting state of encapsulating just how dreadful that process was. And so at this time, like, the ability to change is the scariest, riskiest thing. And so what DevOps, and the people who were kind of building DevOps out of raw clay set out to do was like, well, let's just make change really, really cheap. And we'll do that with automation. We'll do it with configuration management for our servers, continuous integration, delivery for our application software. We're about just 14 years over to the day since the 10 deploys a day post was put up. And then we decided, sysadmins, that we'd rename to operations engineers. We had to rename to DevOps engineers. But it was at this point, the inflection point here is, this is when monitoring like really started to come in the forefront, right? Because this was less like, okay, we're not touching anything, we're just making sure it's okay. This is, if hopefully most people have seen, this is the SRE hierarchy of needs, SRE being like a concrete instance of DevOps, I think the way they describe it. But you'll notice at the very bottom is monitoring, because there's this totally mangled and hallucinated and not actual quote that says you can't manage what you don't measure. But it actually turns out to be pretty true in this specific context. And so you can only change things like as quickly as you can safely verify that the changes had the intended effect. And so it's in this environment that these teams, pushing the state of the art, started building some dramatically more sophisticated open source software to start handling this. And on the other side, you start to see more commercial vendors pop up with more sophisticated web native capabilities. And here, like I said, we're doing continuous delivery, so we get the code out there. If the tests and the graphs look good and the alerts aren't going off, we can rinse and repeat. So next, armed with DevOps and continuous delivery, our next bottleneck is now just literally procuring systems to run the software, right? Like, you're ready to ship code, you know what you want to write, but you have to file a ticket. You have to wait for the stuff to show up. You got to wait for it to be racked and stacked. Maybe you're behind other people's tickets. This is not IT's fault, as there's like orders, like I said, need to be placed, the capacity needed to be management, and importantly, finance teams that had to be satisfied. But moving forward, cloud, at least for me personally, this was probably like the single biggest inflection point in my career. Like as soon as I realized that like provisioning a server could be an API call, like this whole world opened up. And this also then started, led to a new set of tooling because we went from a world where, like I said, hardware very static, hard to get going and provision, to hosts can just come and go. And it's sort of like the software that assumed 2 digits would be enough for the dates for like Y2K, or even better, like we're however many years away from the epic timestamp exploding. But this notion that a host could suddenly be ephemeral, like I'm not sure, back then, kind of the classic joke was like, well, let me show you this graphite graph, and it's like 2 lines, and then the legend is like every single host that has ever reported that metric, because the idea that hosts could just go away wasn't a thing. And on the logging side, where are these logs going to go so we can still use them? Because these hosts are going to go away. They're not going to have local log files. This led to the Elk stack, which led to a million different logging providers built on the Elk stack. Datadog kind of really came to the forefront. That's my little tiny dent down there, or in the bottom. And yeah, I started to work through things like easy onboarding for users, long tails of integration, custom metrics. So bring this to our last kind of shift here. And this is cloud native computing, which when that term arose, if you had been building natively on the cloud for like 5 or 6 years, was like confusing. Because people were like, that's not cloud native computing. And you're like, well, what? Oh, okay. But I think if you consider Conway's law, which hopefully, or if you're not familiar with it, basically says that like there's just no way around, because software, we collaborate in modular format, and the communication boundaries are more challenging at departmental or organization boundaries. Always looks like the organization that produces the software, right? I'm paraphrasing a lot. In theory, high-performing, large-scale organizations should have small decoupled teams. They should each be accountable for a subset of concerns, and they should be empowered to optimize locally. And if you were to sort of then reverse engineer like what the software architecture might look like produced by an organization there, you end up with something that looks something like this. Microservices, we've got your orchestration, there's higher level cloud primitives to push out non-core competencies. Even JavaScript, SPAs and GraphQL fall into this, because I know people get salty and like, SPAs, I'm not a fan, but it allows those orgs to split the front-end team from the back-end team, and they don't have to talk to each other if the GraphQL is set up. And it turns out there's like a lot of value in that. Now, we're reaching the stage of our journey here where there are always trade-offs, always trade-offs. Like none of this is for free. And a thing I like to tell people, which I feel like I have experience from both sides, is like, and politely, it's like, if you're going to use these, understand what you're getting yourself into. Pete has a slightly saltier take, which is okay, but don't die because you're spending more time managing Kubernetes than your product. But maybe more is like, choose your foot gun wisely, okay? Like, understand what the challenges are, understand what you're getting, what you're not, and make sure it's like stage appropriate. If you're early stage, pre-product market fit, and you got a small, tightly coupled team, like you don't need a bunch of microservices and Kubernetes and all that jazz, you just need customers. You will get to that point when you're ready for it. And coming along with that complexity, we now have deep systems, large fan-outs, which are very hard to reason about and have like quadratic communication paths that you have to like put together and tie off. Our metric systems, which are pre-materializing views for known unknowns, which is great. Now there's so many things you want to track, and you say, I know, I'll just pre-materialize all the views as metrics. And it turns out that's how you end up with like $1 million Datadog bill. which they like, but I wouldn't recommend for you. And so we've brought to the forefront things like distributed tracing, the whole observability practice, and what Honeycomb and the team there has done are all kind of driven by, okay, how do we wrestle down this complexity? How do we reduce the cost and what we need to record to do what we need to do? Okay, so hopefully that resonates with people. Where we're heading, or just this is the hot take. And by the way, if you haven't noticed, like a sub-goal of this talk was that like every slide should actually be its own talk. And that felt more approachable when I started doing it than when I was halfway through it. Okay, so first of all, commodity instrumentation. Let's start with a layup, right? Because this is something I want to highlight, because I feel like to people in this room and audience, this maybe is like, oh yeah, of course this is happening. This is not globally and throughout this is happening at the early adopter, but it's not happening long tail in the late majority. And it's something too, open telemetry, previously open tracing and open census. I mean, I was there when Ben Siegelman and the team at Lightstep were cooking up open tracing and specifically trying to address the problem of like, for distributed tracing, how do you ensure you instrument literally every single microservice if the level of vendor lock-in that would imply. And I thought what he was doing, because Ben is just like genuinely one of the like best humans I've ever met, was like super genuine and well meant, but I didn't think it could work. And so where we are today with things like, and there's a couple between OTel, Prometheus exporters, what you can get from eBPF, which the nice thing about eBPF is not just like, oh, we can make automatic instrumentation like portable, but we actually can get net new instrumentation we never could before. And this reduces lock-in, barriers to innovation, and leads to this next area. So this is a little less of a coming out, but it's something I'm really fascinated by. And so one of the great things about observability, and as we went through DevOps and cloud computing, is it created this shared language between dev and ops, where we could reason about production and we could make kind of joint decisions and verify those outcomes. And so developers being able to add custom metrics to their code or spans or use observability tools is really critical to help developers really take ownership of what they run in production alongside the SREs or platform engineers or whatever they're called now. But this missing mode where wouldn't it be nice if you had some input when you are actually writing code as to like, what does this code look like in production? Like this line I'm about to change. Like it's cool that when I ship it, I'll get a graph, but why shouldn't I just know now, like in my IDE? We have the data on these lines of code, or we could have the data on these lines of code. And so there's a couple of teams now working on what I think is really fascinating of really shrinking a developer while they're writing new code, their point of view to just like the pull requests I'm working right now, the lines of code I'm working on right now, and move everything else out of the way, meet them in their IDE. So I think this is a thing that's going to really be widespread. I don't know if it's going to be separate products or if it's going to be features and good products. I don't know, open source versions, I think there should be, at least in the Grafana Prometheus stack, but that's early. Okay. Now, this next one I think is really important. So it's probably a stretch to say that rising interest rates are a platform shift, but like it's going to feel that way to some people, for sure. There's been now 15 years of very low interest rates, which means that the value of very long-term cash flows was very high. We're aggressively inverting that curve right now, and there's still all kinds of unforeseen consequences unfolding. But one that's pretty clear is that teams are going to have to manage all of their costs better. And I really, and this comes from, so very personal experience running a pure monitoring SaaS 10 years ago. The actual very first time I ever saw this GIF, Pete Cheslock was on stage talking about his relationship with my product to an audience in this theater. And so on the one hand, that's not the sweet spot, right? Like I tell all my companies, like, look, if people sign the deal too quick, or if they don't like wince a little bit over the price, like it's too cheap, but also if people are like, no, you're literally, I've got the kidneys, I've got my children, like what else can I give you? Like that is not a good long-term relationship with your customer. But the challenge is that like it's just very hard to scale. Look, at scale, because the impact on your infrastructure of your customers' usage scales linearly, you are reselling cloud at 80% margins. And that's not a good place to be. And I think that we are definitely going to have to find ways, or new ways will emerge, hybrid architectures where the data plane comes on-prem to some extent to address this. A big piece of this, observability pipelines, if hopefully many are familiar with this notion of a stream processing thing that sits in front, very similar like segment.com for customer data, but more for your infrastructure data, that will give you the ability to basically route, filter. I think this is going to be endemic. I think it's going to be part of this. It's going to be everywhere. Cribble has created this category just a few years ago. Gives you this fine-grained, like I said, location where data goes, really the ability to do everything you need to it and maximize the value of the data you're sending to different vendors. I think there will be integrated options. You want to use Datadogs or Mesmos or whoever's, you can use their in-house. I think primarily it'll be standalone just because the incentives are really disaligned there. Yeah. So the last one, sorry, I meant to say, well, we're done, right? Well, except if you want to know if there's a platform shift, just find out wherever VCs are losing their goddamn minds. And like, you will have a sense. So we've got just a couple minutes. All right, so generative AI, so this, yeah, definitely fits our definition of a platform shift, a broad definition. Like, there's some people who are like, oh, this is the new cloud. It is not the new cloud. But it is going to impact a lot of different things, and probably maybe more different things than we've had in a while. We're super, super early in figuring out what any of this all entails, where the limits are, where the value is. And Gates' law, this thing where like we way overestimate what can be accomplished in a year, and way underestimate what can be accomplished in 10 years. This is the like most burning example of this in my 25-year career. I'm super long bullish, and like I just wish the noise would calm down a bit short term. Quick framework I use, and this prior to LLMs, even just with ML, same thing. So when I'm thinking about uses of AI, it's like, well, what's the acceptable false positive rate? Like if this is the thing I'm doing, and if it's 90% correct, it helps me. That's great. If this thing is gonna send me a page in the middle of the night, like 80% correctness is not okay. And this has been like the, in the sense of superpower, another way to look at it, does it give a human superpowers? I'm for it. If it says it's going to replace humans, I'm very skeptical. And I think generally these are not like standalone, we're the AI this, we're the AI that. It's a thing that should give people seamlessly better experiences in your application and its usage. Yeah, just running through things I think are laughable. LLMs are not going to reduce the number of software developers. They're not going to, observability specific, detect all anomalies in your systems. It's not going to predict all your maintenance. There's been 20 years of just, there are like two kinds of AI ops. There are two kinds of AI ops companies, dead ones and new ones. And like, that has been the case for 20 years. That may change. I'm always open-minded to a change. But when I see a pattern like that, it's, I have to understand why. And just the reason for that, like I said, is the framework there. It's just systems, our systems are constantly changing. There's no pre-training data. And lastly, like specifically, LLMs will not replace you. By the way, I was doing this. I was like, you know what? I should ask ChatGPT if it thinks it's going to replace software engineers. And it turns out ChatGPT is actually smarter than most of the people like relentlessly tweeting about it. But it gets it. So I think they'll figure it out at some point too. Now, and yep, we're coming in because I'm right on 30. So Pete, has got the hook right there. Yeah, so this is what they're going to do. It's going to give experienced developers superpowers. It's going to help your new developers learn faster. I think is really exciting. These next two, I think has a lot of promise. Just like things like crazy query languages, like Honeycomb. You should check it out. They've done some really cool stuff. It's just like, well, hey, instead of having to remember HoneyQL or whatever it is, like just ask us a natural language and we'll mostly figure it out for you. And that's the kind of thing. Making just easier to use tools like is a really, really valuable thing. And ultimately, like I said, I don't think it's going to replace people. I think it's going to, especially software developers, it's going to just make you way more valuable. Last thing, the very last thing, these foundation models, all this is built on right now, these are black boxes, not just in that you literally can't see inside, but also even the orgs that build them you can't see inside or understand. It seems likely, barring regulatory capture attempts that I feel like are going underway, it seems likely that there will be open source models that complement this and that people run themselves. And if that's the case, then there'll be pipelines and infrastructure, and you all will be on the hook for helping your teams understand, like, is this working well? How much is it costing us? Is our user like happy or completely just about to get violent because the bot is not doing the right thing? And these costs, and not just training costs or inference costs, but like just the ongoing carbon costs, I think are going to be important to know with these because this is not cheap to run. Okay, cool. That's about it, I think.
All right. Do we have any questions from the audience for Joe here?
I didn't agree to questions.
I mean, they know you're a VC, so they're already very
Did
cautious.
Did my PR people vet the? No, just kidding.
Awesome. Was there a question out there? It's so bright up here. I can't see anything.
Yeah, I can't see a thing.
Oh yeah, over here. Thank you.
So one of the things.
Oh, hi, Adrian.
Monitoring sort of gone down. Like one of the generational changes from the enterprise monitoring is that the cost of monitoring tend to go down. But one of the problems I've seen is that the cost of monitoring compared to the thing you're monitoring has been going up. So if you got like a serverless system, you can be spending more on monitoring than the cost to run the thing. So is that causing breaks? How do we end up making enough money at a monitoring to build the thing that you have to do to monitor the thing you're trying to build?
So I'll repeat the question real quick. It's generally the cost of monitoring has reduced, but we're kind of approaching a situation where it costs more to monitor the thing that we're actually monitoring. So like, how do we deal?
Yeah, it's interesting. It's funny. There's a couple pieces of prior art that kind of always come to mind. So one is like when New Relic first launched, well, not launched, but when they first came out, their very first add-on on Heroku, like to some acclaim because Heroku as a black box, like you couldn't shell in, you couldn't do anything. So like anyone doing production on Heroku had to pay for New Relic, and they were charging 1 cent more per dyno than the cost of the dyno, which at the time it was like 5 cents a dyno hour for the dyno. 6 cents a dyno hour for New Relic. And that just made my head explode then, because how could this make sense? The other one is, I remember in 2012 talking to the person running observability at Netflix who told me that 25% of their bill, AWS bill, was observability. And again, I couldn't believe that, because at running a startup, we were like, well, we can get maybe 5%, and anything over 10, we're getting kicked right out. Which, by the way, an interesting thing of, I ran 5 or 6 different observability products, all with different characteristics at SolarWinds, and every single one of them, it fascinated me, had a different high price mark over which churn went through the roof, right? And for some of them, it was 5K a month, some was 50K a month, some was 100K or more a month, but like every single one of them, there was like this high water line over which people were just like, I can't do this anymore. Bringing it back to your question, and this is part of why I had the slide on that, is I do really think like the part of the cost that increases linearly, if we're talking at scale where it's like not just that it costs more, but also it costs like a lot, right, as I scale my business, I think that just has to get broken, and with the data plane costs, we have to have the customer pay the data plane costs at their like rock bottom wholesale cloud prices, and we see where we get there. A pure serverless is a little tricky on that, but I think potentially can be done. But yeah, that's why I don't believe that like pure SaaS, we're going to resell cloud at 80% margins is viable 10 years from now.
Awesome. Any other questions from the audience? Oh, one over here. Thank you.
Do you have a ballpark figure for what percentage companies pay?
Do you have a ballpark idea of monitoring costs as a percentage, like a percentage of cloud spend?
Yeah, well, I think where we're at right now at scale, and this is why I think Adrian's question is important, is you know, like I said, 10 years ago, it felt like 5 to 10% was as much you can get away with. And like the Netflix number was this huge outlier, which, by the way, the individual at the time reminded me that Netflix content budget was, I forget how many $1 billion. So there was literally nothing they could do on AWS that would move the needle. So that was kind of a special case then. Now, I think the 20 to 30% number is a lot more prevalent at scale. And I think that's really, really dangerous for observability providers to think is okay. Because I think it's the lowest level of that hierarchy of needs. And if that's the only way to do it, you're going to do it. But people are going to be very, very motivated. Like, you do not want your customers to have at the top of their priority list, like, whenever it comes up, try some way to get this down, right?
Not that this is my talk, but the one topic I'll put on that one, which was Amazon cost management tools became important when the Amazon bill showed up in a board meeting. And I guarantee you, because I've heard this from board members of public companies, observability bills are showing up in board meetings.
No, a million percent.
And not just Coinbase's ridiculous one, right? Like many others.
Yeah, no, I mean, that's actually true. I mean, in many cases, to Adrian's point, like the second biggest bill after your cloud is observability, your SaaS observability. Or if you're being honest right now, like if you're running like a team of 11 people with open source software, like that's not any better. So I don't think this is a solved problem.
All right. One more question. Any good references to how to better spend on monitoring?
Sorry, when you say better spend, do you mean like at the bill down or?
More like to help provide leadership with this is the ballpark that is reasonable versus.
Oh yeah. Not because that just tends to be sensitive data. I mean, I do think there's kind of so much ambient. You could probably throw together some kind of qualitative. There's just so much kind of ambient anger and complaining about it. And I do think periodically you'll find, obviously biased, you'll find something a vendor will put up will be like, oh, of course you want to spend this much. But yeah, I would focus my energies on like I said, like what are the future ways likely to help you get better control over that and more fine-grained, the signal to noise ratio on what gets sent out to who, because they all charge by volume, right?
Awesome. Let's do another big round of applause for Joe.